structured this talk is a little bit more of a conversation between the two of us. We're going to talk about this specific project in Haliburton, talking about design philosophy, materials, successes, challenges, and just how they navigated through the different projects phases. So why don't you just start off, Jeremy, by telling us a little bit about the project. So who was it for? How big was it? Where is it located?
Sure. So the project is up in Haliburton, right near Sir Sam Ski Hill. So it's a beautiful country, and it was a relatively flat lot with quite a bit of space. So we didn't have too many restrictions there. It was for an older couple who wanted it's a long-term residence for them. It'll be a retirement residence eventually, and for now, mostly just kind of like a cottage. And so they wanted it to be energy efficient over the long run, affordable to build, of course, and made with good materials, avoiding toxic foam materials, things like that. And we talked about Passive House and going for that kind of standard and nudged in that direction, but ultimately for them it didn't make sense to do the full certification. So we used that as our baseline and reach for those levels, those performance levels, but we didn't certify this project. So I think that's the basics for it.
Well, it's interesting that you mentioned foam-free, because I think one of the big philosophies for those of you who have worked with 475 is really this move towards the smart enclosure system, which is looking at providing comfortable, healthy, non-toxic, and low-carbon materials. For those of you that are curious, 475 is a reference to the Passive House standard, which requires 4.75 kilobTUs per square foot per year, which is the heat demand requirement for the standard. It's a question I get asked all the time. So the smart enclosure system really is about progressing towards that low carbon future, and we provide lots of details and steps to get you from kind of business as usual to kind of where we need to go. And I think what was really exciting for us is that Simple Life Homes, and in this project in particular, those philosophies really aligned quite well. So maybe just before we delve into the materials, maybe you can talk about kind of the design philosophy from a space perspective, and how you approach that.
Sure, yeah, so this is a quick spread from, I think it's about a year or so ago. And a lot of you probably have these books or may have written part or all of them. So for me, it's quite humbling to be standing here because I just read those and take the info and try and use it. But for this particular project, I mean, the design, like I said before, it's a beautiful space up there. So we had to look at the lot, of course, and say, okay, how can we position the house? What do the clients need in the house? There's just the two of them. I mean, solar orientation is something that we talked about, but wasn't, because we weren't certifying, it wasn't on the top list of the radar for things for them. And what else did we talk about here? And basic design was sort of, the parameters are pretty wide open. They said, we want a beautiful house with lots of light that uses clean materials, and so it didn't really narrow it down. So we had sort of free reign. So we worked with Andrew Smith Design in Coburg. He's an architect there who helped us sort of rifle through some plans, and we looked at what we thought made sense, and basically got little to no pushback when we presented it and said, here's what we think we should build for you guys, and they said, great. So that was nice.
How much of building a damn good house influenced the design?
Sure, yeah. So I was bugging Erika earlier. I said, can I say this? Because although we couldn't hit Passive House levels, the GGH thing has become a big deal for us. A lot of people want a damn good house, but they aren't necessarily certifying. So it was a big deal. They wanted energy efficiency. They wanted it to be beautiful and comfortable and affordable and all those things. And so it was key.
So that's what you gave them?
So we gave them a damn good house, I think. I'd like to think so.
So part of that is really about the materials, and you've referenced, wanting to do non-toxic, looking for obviously getting light in, and you've touched on the design features. what was your process for that material selection, and how did you go through that decision making?
Yeah, so the books that you saw are super key, and there's one in particular by Chris Magwood that is sort of the Bible of materials, and if you don't have it, you should have it, because it's phenomenal, and it's a nice way to just say, what if we tried this, and flip through and pick something that tells you everything you need to know. So I don't know the exact name, but we can look at it after. We also have just our sort of arsenal material that we always use on projects that's always growing, and a lot of you who I know well are a big part of that sharing community of what materials we like and where to get them and why we like them and those sorts of things.
Were there any materials that you wish you would have had on this project?
Gravel.
Long story, but
yeah,
coming soon, hopefully.
It is, there was, we've got sort of a couple different sources of everything that we get, really, and so you have to look at costs for them and availability and the location of the site. Sometimes it's just too expensive to get stuff to that particular site. Also, just having guides. We have the 475. If I say 475 5 times, I get $100 at the end of this. I really do use that website a lot because the guides are amazing, and even if there's something in there that, like they specify plywood in one of their guides, and that's not something they sell, it's just a great option. So looking through the rationale and learning about why we use what materials in what places. A lot of that learning I've done through the 475 info and blogs and website.
That wasn't planned, by the way.
It was not, but it's the truth.
Okay, well, in terms of process, now we get down to kind of the nitty gritty, and the foundation is always a challenge when it comes to, again, thinking low carbon, thinking less foam. How did you guys approach the foundation part? Because I know you tried a few new things as well in this project.
Yeah, even looking at this picture makes me a little just tired, and the foundation's always challenging for us because even as of I would say 2 years ago, we were still just pouring concrete and kind of doing it the way we had been doing it in the past. And there are some options like gravel that are coming, or pour-over or stuff like that. So what we did here was kind of a combo. Like we weren't going to use foam. We wanted to use as minimal concrete as possible, and obviously use all as clean material as we could and store as much carbon. So the balance between that was a concrete footing, the Nexem ICF block, which is a recycled wood chip and cement block, and then I don't think we have a picture of it, but then once it was backfilled, there was a concrete slab poured inside the garage in the house, and that was poured on top of 3 layers of Comfort 80, which is a semi-rigid mineral wool product. So it's not like a bat, but it's not quite like rigid styrofoam. And that was frightening, to be quite honest, to have the concrete truck there and 3 layers of this rigid or semi-rigid mineral wool insulation that we were excited to use, but didn't know if it was going to work. But it did work. And we poured the concrete on top of that insulation, and when you sort of jump and stomp on it now, the whole thing echoes, and that's a nice feeling because you get a sense that it actually is floating. And I think in the future, what I'm really excited about for the foundations, I know I'm being cued to move forward, but is rubble trench foundations and slabless slab designs, which is not a joke, that's a real thing. Slabless slab is a really exciting option.
And we can circle back on both gravel and slabless slabs at the end. So tell us about the panels, because you're a prefab manufacturer, you're moving these things around. How do these get built? Where are they built? Yeah,
so that's a snapshot from our prototyping days, which were a lot of experimentation with moving panels. And the big thing for us in this last sort of year or two is figuring out what kind of panel we wanted to build. And figuring out the right assembly. Eventually, we had to start sort of narrowing that down, and now what we build is sort of the most carbon-conscious, flexible panel that we could come up with. Not flexible in the sense that it will bend or break, but flexible in the sense that it's got varying options. So if you need a certain level of performance in one project and higher in another, we can work within a certain range, which is really important. So we're manufacturing wall panels. There's no standard sizes. They're basically custom. They have some limitations, but generally if you can draw it, then we can build it. And we also, as of 2019, are now doing roof panels, which I would love to show you, and it fits very nicely on top of our nice wall panel display over there, but it's in the shop. And I have the keys here.
You're jumping ahead. I wanted to ask a question about these. On this project, what kind of R value were you looking at for your wall?
Right. We achieved, I think, R42 was what it was for the wall.
You tell me.
It was, I'm trying to think now. So for this particular project, it was R42, and so that's with dense packed cellulose inside of a I-joist cavity. And we didn't choose to insulate the stud wall for this particular project just because they didn't need that level of performance, basically. And then, yeah, we didn't do roof panels here. We just did a conventional truss roof.
That's a great segue to our next slide,
Okay,
which
great.
is about the roof.
Super.
What's the makeup of that panel?
Do you want to just, touch? I
sure.
think you
So
just ran through the...
It's a 2x6 structural wall, and then there's, this particular one has a 2x6 wall, and then in a layer of Intello from 475, and then 1.5 inch wood fiber, and then an I-joist, which was a 12-inch or 11 7/8 I-joist, and then the Mento WRB, and 2 layers of strapping.
And blown cellulose in that cavity.
Of course, yeah, inside is the cellulose.
So in terms of the roof, you've touched on it briefly. You used a truss roof in this particular project. Why did you decide to use a truss roof and not use panels?
Erika's snickering because I complained for a long time to her about using a truss roof in this project. A truss roof is great, it's super efficient, and it worked well here. But what happened was we installed the wall panels in about a day and a half, 2 days, and then we spent weeks putting the trusses up, bracing the trusses, strapping them, putting the membranes on, insulating, doing the overhangs, all the stuff that goes along. And if you've ever framed a roof, you know it's a bit slower because you're up there and you can't just hop down and get what you need. And so we sort of stood back at the end of it all, and you know, at this stage right here, I'm taking this picture and sort of said, why didn't we just build roof panels? And I think the answer was we're too excited about the wall panels, so we just did those. So that's why now, this year, we're starting to do the roof panels because there's a great application for them. Like I said, it doesn't suit every project or every situation, but generally they're a great option.
So what's that structure going to look like then in your roof panel?
So the roof panel is an I-joist panel. So the structure is made up of an I-joist. Again, varying depths depending on unique situations. On the interior side or the ceiling, you would see strapping and Intello. Then there's obviously dense packed cellulose inside. On the top side, we have the 1.5 inch wood fiber, the Adhero membrane from Proclima and the guys at 475, and then 2x4 or 2x3 purlins on top of that to give you a ventilation channel and a base for your final sheathing or strapping layer or steel roof or whatever you may have.
So, air tightness, as soon as you start adding air tightness, insulation levels, you start to have higher risk, as everyone knows, of managing moisture. What steps did you take and how did you ensure that there was no kind of inherent risk in that assembly? Did you have any concerns, and what did you use to gauge that?
Yeah, well, we haven't been doing this kind of building for 20 years, so every project I feel like we learn little bits. And the more we get familiar with the smart membranes and the Proclima products, the more we learn about not just how they perform in the real world once this assembly is finished, but during construction is a huge deal that I think is overlooked because you're building a super insulated assembly and you have to be careful. We poured I think 2,000 square feet of concrete slab, and then you proceed to close it, and that moisture over the next weeks and months is going into the air. And so because we use the smart membranes, we don't have as much of a worry as we would have in the past, which is nice because we know that they will stop moisture going into the wall and allow the wall to dry outwards. We have done woofy modeling in the past, but for this assembly, this is really similar to what you see inside of the 475 booklet, and so we talked with those guys there and sort of determined we didn't need any further research on it. As tempting as it is to stick little sensors behind the sheathing and wire them up to your phone, we didn't do any of that here.
But you bring up a good point, because I think we always design for moisture diffusion through materials, and we never design for wet construction. And the amount of moisture that you get into your building assembly with constructing with wet materials is significantly more than what you would get simply through diffusion. So I think that's something to keep in mind. It's not always avoidable, but certainly something that is really important and that we often forget. So, what's your biggest success on this project? And you know what the following question is going to be, so.
I was about to, I guess I'll hold off. There was a lot of firsts, and I couldn't come up with one, although Erika was pushing me to. I really feel like there was a lot of successes here. The slab was a big deal for us, because that's a huge step away from foam, which is an important goal for us as a company, and I think all of us as a group. We did the prefab panels for the first time, built them, loaded them, shipped them 2 hours up north, unloaded them with the incorrect equipment, installed them with the incorrect equipment. It was really challenging being up there, finding new crews and finding new suppliers, and that was one of the things we learned, but I'm not supposed to go there yet. We got some great performance tests. Yeah, so first time we did it, it came back at 1.2 or 1.12, and then we realized that there were some plumbing penetrations through the slab that were, even though they go through the gravel and down and around and up, and there was a ton of air coming through there. So once the showers were installed and water lines were sealed, stuff like that, we were down to 0.62.
Well done, well done.
Yeah. How much time do we have?
2.5 minutes.
Is this our last?
This is our last slide before the questions. So, I mean, if you want to use it all up on challenges, go for it.
Well, I think the biggest thing for us up here was there's a ton of snow in Haliburton. And we started late. We couldn't get our plans on time. We got our plans, I think, August 20th. And I scrambled and got permits by the 23rd of August, within like 2 or 3 days, and just got right over there to get going. And it was sort of like on the edge of what we were comfortable with starting. It was a big project. It was far away for us. We all live in east of Toronto along the 401 corridor, so it was 2 hours of driving there, 2 hours of driving back. We were up there 4 days a week, so right away you've lost a day. So the project took longer than we thought, and then we were into winter. And as soon as we hit winter, then it was really tough. Siding in January and February in that was, which was not that long ago that I was standing on that ladder. That's a photoshopped error.
I was going to say, has nobody seen that product?
All of the safety vests are hidden.
How did you insulate those?
In the snow.
The roof was insulated as normal, loose blown cellulose. Yeah, above a membrane on the bottom of the trusses. Yeah, with strapping.
Any other challenges before we wrap up?
Yeah, I mean, like the foundation is still a challenge. I really want to get on to doing the Rebel Trench. It's such a great, simple, effective option. I haven't had a chance to do it, but I know a few people in the business who have, and I think it's a great way to get rid of some concrete. Again, it doesn't work in every application, but this was really challenging. We didn't have any pictures of the footings, but there's bedrock in this corner right here, and it goes from 8 feet up to 1 foot at the corner, and it comes up the rock and then back down the other side. And so, that was hard, just the terrain, the weather, the traveling, that pushed our timeline into winter, the weather slowed us down. So they're not necessarily, super unique to this project. I think that's why I really like the idea of prefab building, because it's just always warm in the shop. So.
Well, thanks so much. This is really a great project, and we're really excited to see what you guys do next.